Welcome to our Unit 2 test review, starting with number 1. Read through this carefully. You can always pause the video if you think I'm going too quickly. But we do have a situation here where we're talking about one adult male, and we've got this distribution that looks like this, given. And then we're being asked about combining, 4 of them. So you might think, oh well, I need to combine, four men, and then I'm going to have to do that trick with adding the means and then adding the variances. But really, we just need to make sure that our average doesn't go over 200 pounds, right? We have 800 pounds total divided by 4 men. So it's really not combining means and variances here. We're just sampling 4. We've got a sample size of 4, and we need to make sure that the average of that sample, the mean of that sample, does not go over 200. So let me switch to blue here and then see what our question is. Our question is, what is the probability that will go over 200 here? Okay, so that's, you can see that's 10 pounds. Our z-score is going to be that difference. I'm just going to write it as 10 pounds. 200 minus 190, divided by standard deviation. But are we going to divide by 10 and get a z-score of 1? No. We are going to use, where can I write this? Down here, I guess. The standard deviation of the sampling distribution, which of course is cut down by square root of 4. It's so nice that they did that because we can do that in our heads. 10 divided by 2 is 5. And our z-score is 2.0. Now you can look up 2.0 on the table and get 90 something, or you can look up negative 2.0 and that'll tell you that number, which I have right here, 0228, which 0228. Okay, and then they rounded that to 3 decimals, so we have that here. For number 2, there's not much to say here except for a warning. You could put all of these numbers into L1, and then you could put all of these numbers into L2, and then you could forget to tell your calculator that you have an L1 and L2. And if you do that, you will get just the average of 1 through 7, which is right here. And you would get the answer 3.5, which you may notice they have as a distractor. But why isn't it 3.5? Look at the probabilities. The probability of getting a high number is quite low, and the probability of getting a 0 or a 1, well, you have more than a 50% chance. So the mean is dragged way down here. And the correct answer, I won't do the math here on the screen, but if you do this multiplication, add them all up, or put it in L1, L2, and remember to tell your calculator, then your mean is right here at 173, 179. Number 3 is about a spin the wheel charity game, making money for a charity. And if you read the question carefully, we are getting $2, but then giving away money. Sometimes we give away 0. Sometimes we give away $1. Sometimes, if we're unlucky, we have to give away $10. And I've written down the answers. For A, it's pretty easy. You count up, there are 10 spaces, 6 out of 10 chance that we give away $0, and only 1 out of 10 chance that we're having to give away the $10. The expected value, well, we take the $2 multiplied by the 60%, add those three terms up, and we get an expected value of 70 cents. So on average, 70 cents a game is our profit, which is the answer to B. So A, distribution, B, expected value. Let's see what it would take for us to win a certain amount of money. Okay, so part C is we want to earn $500 for our charity. Oh, I can't get my pen to work, sorry. We got this, come on. Nope. There we go. $500 for our charity. And what is the fewest number of times a game must be played? So our expected value is $500. And we know we're going to get 70 cents a game on average. So the question is, how many games would we need to play? Well, if you divide over 0.70, you're going to get something like 714.29, but we can't say that's a number of games. And in the grading guide, it actually says to mark off a point out of 4, so 25% off of this whole problem, if you have not made this an integer, because you don't recognize that this is a discrete number, and we would have to place at least 715 games. The last part of question 3 asks for a probability calculation of at least 500. So let's take a look at where that would fall on the curve. We've got a mean of 700, so 500 is going to be out here, especially since I know my standard deviation is about 100. This is about 2 standard deviations to the left. Exactly how many standard deviations? You could do this in a calculator with a normal CDF, or you could go ahead and divide 200 by this number to get a z-score of negative 2 point something. And this would give you just a little bit less than 2% of area here. And you take 1 minus that and get 0.9844. One last thing about this problem. First of all, it's not 2 point something. It's negative 216. Your z-score would equal negative 216. That's how we get that little piece of probability over there on the left. And we did not divide our sigma by square root of n here. We're not talking about a sample average. We're actually talking about the probability of one value happening. So we need to keep track of the difference between a population bell curve and a sampling bell curve. Let's move on to number 4 in a different video.